Okay, welcome back to Dublin Academy of Maths. Now today we're going to do statistics, and we're on series 11, episode 2, paper 2, question 6. Okay, so it's all with paper 2, and we're doing, in this case we're doing question 6 in 2012. Okay, and it's a stem and leaf approach here. Okay, I'm going to get into it now. So I'm going to show you how the question reads. Okay, so the question reads, here's the question. Question 6. The students in a 2012 Leaving Cert class decided to investigate the heights. They measured the height of each student in centimetres, and the results were as follows. So they have them all mixed up, okay? So you've got 149 down here, next one 174, and beside it 157. So they're not in increasing order, okay? So you have to rewrite this table. When you get an array of numbers like this, you rewrite the variables or the numbers in chronological order, from the lowest to the highest. Okay, so I did that from the lowest to the highest, and I got this. Okay, so I went from the lowest to the highest, and it said find the mean. Okay, well it didn't actually, but we want to find the mean of this. So I went from 149 to 187. Okay, so how do I find the mean? I add them all up on the top bar. Okay, it's the sum of all the x's, right, divided by the number of terms. Okay, so the number of terms is 1, 2, 3, 4, 5. 4 by 1, 2, 3, 4, 5. 4 by 20 plus 4 is 24 terms. So you add them all up and you divide by 24, and that will give you the mean. It's such here. Okay, so that's how you find the mean of an array of numbers. But they will help you in the second part of the question, because in the next part of the question they says construct a leaf and stem plot of the above data. Okay, so with the above data, so I had to rewrite this into a form so it's easily readable. So this is 149. Okay, so on the left it can be 148, but I'm doing it on the right here. Okay, but the width later will be a split. So I've got 149. How many times does that appear? It only appears once. Okay, so I've only wrote it down once. 9. Okay, so this is 140, and the next one is 157. 157, and that only appears, 15, 7. Okay, so these are the 10s out here, and because they're common. Okay, and there's only one of those, and it's the same with 16, 160. I've got 1. I got 161. See what's happening here? 161, and I've got it twice. Okay, so I must write it down twice. I have got the next is 164. I'm reading over my array of numbers here, as you might have seen. I'm looking at my array of numbers. You probably won't be able to get this in. And I'm filling in my form, and I'm looking at 160, 160, and it appears once. So I put down 161 twice, 1, 164 once. Okay, and I keep going along until I get all out my digits, all my numbers. So you got 164, and then you got 166. Okay, and that's only appears once. Then you got 167, which appears twice. Okay, so 7, 168. Then you got 168, and you got 168. Okay, next is 17. So you see you're going on the hundreds, or the 140. You're going up in tens. All right, so 17, 170, 171 twice. We got 171, 2, 3, 4, 5, and then 2, 3, 4, 5, and we got 2 6s. Okay, and then we got 1 and 178, and the last one, and we won 18 and 180. We got 2 of them here. Okay, and then we got 187. We got the 187 here. Okay, so I'm rewriting it out, and as you can see, there it is there. Okay, now that's the stem and leaf. This is the stem and this is your leaf, and you can see there where the range, where the variables are all, where the mean variables is line. Okay, now let's look at the other parts of the questions. Now it says describe the distribution of the data by making one statement about each of the 3 characteristics indicated below. The shape of the distribution. Okay, well, you can say that the shape of distribution, you can use all sorts of words, but you have to read these very carefully. Okay, and restrict your comments to one line. Okay, and be very economical with your words, like politicians. Okay, don't get yourself, dig a hole for yourself. So you can say the shape of distribution is that it's starting to look like a leaf. The distribution lies around 16 and 17. Okay, the majority of the distribution lies around 17. So the there's a name called, and it's called what's it called? It's the range, or the what's it called? The oh, anyway, I'll get back to it again. It's the average here is I'm after forgetting it again. It's out of my head. Right, I can't chase it. Anyway, it'll come back. So that's how you represent this data. Okay. Now, location or central tendency. Okay, so central tendency is here. Okay, so that's the central tendency. That's where you find the mean and all, and the median tendency. Okay, so that's the median. So the location of the central tendency is in around 16 and 17. The shape of the distribution looks like a normal leaf pattern, stem and leaf pattern. The spread of the data is confined to 16 and 17. Okay, which 160 to 170. They're 279, I should say. 160 to 179. Okay, so remember, it goes up to here. Okay, so those 260, they're up in the 7-9 area. Now, it says that these were all the mixed students, so it says that the students were then rearranged to males and females, and then they were plotted again until, and they were giving the same numbers again, but we now have a double leaf and stem and leaf plot here, because now it became males and females. Okay, so we will change it over. I'm rewriting this because I don't want to draw it out again. It takes too long. And we got males. Okay, is that the way it's going to go? That's the way it's going to go. It's females on the other side, really. Okay. Males and females. Right, now let's, I'm going to just throw in the data here. So we've got 149 for females, 157, 16, 0, 1, 1, 4, 7, 7, 7, 8, 1, 2, and you got 0, 0, 7, and you got 0, 1, 3. Okay, now this extends out. Okay, so you really want to, you know how to draw these out anyway. You don't need me to do it. And you get this array of numbers. 18, there's none for women. So 0, 1, 3, 4, 5, 6, 6, 8. Okay, and the next one you just got 6. Right, now, right, so that's the males and females. And the questions, it says construct a back-to-back. Okay, so this is called a back-to-back stem leaf. Back-to-back. Okay, back-to-back. I need to write it out. Back-to-back of the above data. State one difference and one similarity. Okay, so it gave you the males and females, and all you had to do was rewrite and put on the left hand side males and on the right hand side females. Now the only problem is reading it. You might think that's 16, that looks like 616, when in fact it's 166. Okay, so it's this is the main one here, and then you work left, it doesn't matter which side you are, but they're on the digits. This is 160 on the right hand side. Okay, so you have to think backwards and you have to use your brain. Alright, now you must put down a key and represent the key. It doesn't actually have to be there. I mean, I could represent this as 13. 9 represents 139 centimeters. So long as I have the key in here showing me that this represents 100ths, which will give me 139. Okay, now the thing here is to find the quartile ranges. Now how many elements have we got here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we've got 12 elements here and we've got 12 elements here because originally we had 24 elements. Okay, or 24 terms or 24 numbers, whatever way you want to look at it. Now, so I have to find Q1. Now for me to find Q1, this Q1 is the first quartile. Now that means that when you used to have these graphs, it'd be the first 25%. Okay, so it's the first quarter of the array. Okay, so the first quarter how can I calculate the first quarter? Well, it's the first quarter is a quarter of the pieces of information. Okay, so it's quarter of 12, which is equal to 4, which is equal to the third term. Okay, now if I'm finding out the third term, I must also add the fourth term and divide by 2, which gives me an exact measurement. Okay, so for the males it would be the first. So this is the first term for the males, second, third. So it's going to be 171 plus the fourth term 173 divided by 2 gives me whatever it gives me. 173 plus 171 equals divided by 2. And you know it's 172 anyway, you know. I don't know why I use the calculator to show that, you know. But anyway, 172 is the first quartile. Okay, now remember that I'm looking for, so I'm getting the quarter of the 12 terms. I'm looking at it as the terms, the number of term is 3, the third term, and I add the fourth term and divide by 2 to make sure that I get the mean of the quartile of the first quartile, if you see what I'm getting at here. So you're reducing your chances of error. So the first quartile is 172. Okay, so that's the first quartile. Now, what's I have to find Q3 in order for me to find the interquartile range, because the interquartile range is the difference between the two of these. Okay, so Q3 is the third quarter. So I have to get the third quarter of 12, which is 3 quarters of 12. Okay, so I multiply by, divide by, so it's equal to 9. Okay, so it's the 9th term. Okay, so I go along again and I look at males. I'm doing males at the moment. Okay, so this is all relative to males. I'll be over on females next. And so I'm looking for the 9th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 1, 7, 8, plus the next one, 180, divided by 2, and it's 179. Okay, 179 is the next is the third quartile. 179. Okay, you can add them and find out. I think you'll be lost cause. Now, if I want to find the interquartile range, I hope you can see that this screen isn't the best. Interquartile range is 179 minus 172. Okay, so that's the range, and the answer was 7. So that's 7 centimeters. That's where it lies. The interquartile range is the average in around 7 centimeters. Okay, so it's the difference, right? So that's the range of values. Okay, 7 centimeters. Very good. Now let's we'll leave that there. So let's look at the females. Right, you can start thinking now for me now for this one. So females. Now let's look at the first quartile. The first quartile is Q1, and it's the first quarter of, and we've got how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. Okay, because we decided that. So I have to look for the third term and the fourth term and then divide by 2. So I got 1, 2, 3. So that's going to be 160 plus 161 divided by 2, and you're left with 161.5. 160.5, and that is the first quartile. Okay, 160.5. Next I have to find the third quartile. So I go down and I look at the third quartile, and look, it's the third, it's a 3 quarters of 12 divided by 4 is equal to 9. So I must look at the 9th and the 10th term and then divide by 2. So I'm looking at the 9th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 167. 167 plus the next term, which is 168, and divide by 2, and the answer is 167.5. Okay, And the interquartile range, okay, I'm going to rub this out. 160, 167.5. So that's the upper, that's Q3. This is Q1. I subtracted both of them from each other. I'm taking that out. So 167.5 minus 160.5, and the answer is also 7 centimeters. Okay, so their range is in with 7 centimeters. Right, very good. Right, so that's the answer to that one. Another one is, now, say for example I have only, we leave the one there. Say for example I have only, no, let's say we have another one. Make it 3. So say I have 13 terms here, right, and I have to get the first quartile. Okay, so the first quarter is a quarter of, so I divide it in and I find that it's 3.25. Okay, now I round down, and that's my range. That's my first Q1. Okay, is my range is 3. Okay, so I don't need to add. So I look for my third term. 1, 2, 3. So there it is. 160. And because I've round down, I cannot do. I'm not adding. We don't add another term to get the average. Do you remember we had the average? We got the third term, which is 160 plus 161 divided 160 plus 161 divided by 2. No, we don't do that. In this case, when you have a fraction, when you are at decimal place, you round down to its 3, and then you just take the third term, and the third term is the Q1, and the third quartile, or the third quartile is that's divided by 4 multiplied by 3, so that would be 4 3s is 9 points. Actually, that works out as an even number. Okay, so you will have a problem. You will have to include the second number there. But remember, let me just check that out. So let me have 4. That wouldn't work out. 4 into 13 goes where is it? 3.25 multiplied by 3. No, so it's 9.75. Okay, so I have a fraction here. I need to round down, so I round down. That's approximation is 9. My ninth term I use 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 is equal to 167. So the interquartile range is 167 minus 160, and the answer is again 7 centimeters. So you can see that the accuracy here is excellent. It's on 167 minus 167 centimeters. So you can see that the way they go about this rounding down does work out. Okay. Right then, wow, so that's good. Now that's the interquartile range done out. Anything else here? It says comments. State one difference and one similarity between the two distributions. Okay, between the two similarities is that two similarities. Well, you just look at it long enough and maybe something will come up. You could say that that their distribution is just is 10 centimeters. It's how far is the range? It's from, it's nearly 10 centimeters in the difference. Okay, so you would say that on average that in the median, in the average here, which I must do is the median. Okay, but in the average here that there seems to be a difference of 10 centimeters. But really it's your interpretation of the graph and how you interpret the graph. Now I'm going to just show you a few other things. The mode is the most common element. Okay, now the mode in this case is 167 because well, we've got a couple of modes here. Okay, 167, 171 and 180. Okay, now 180 actually is the mode here. Okay, so the mode is 180. Most often, most often. Okay, appears the most often times. Now the next is the range. Now what's the range? You take the highest minus the lowest. So the highest is 187. The range is 187 minus the lowest. Okay, so you could be asked the range of this originally of this mixture, or you could be asked the range of the females. You know, I mean, really. You can do your own statistics from the stem and leaf graph there. But anyway, the range is the largest minus the smallest. and you get out an answer, and you get that the range is equal to 38 centimeters. Okay, that's the range, which is a huge range. Okay, and you can make a comment on that, right? The range is huge. Now the next here is the median. Now how do I calculate the median? Right, now well, the median is I have to start, you know, I could count, well this is what I actually do. Okay, so I keep going and I keep down until I get to the, so 4, 5, 5, 6, 6, okay, let's check that, 3, 1, 2, 3, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 7, 8, 8, 9, 9, 10, 10. Remember, we're going down and this is going up, okay, so don't get too confused. Okay, so 1, 7 now, 1, 7, 2, and we got 1, 7, 1 in the center. And if we have got two of them in the center, and they're different, we would add them. We would, 171 plus 171 divided by 2 is 171. But if we had 172, we'd still, if we have got two numbers in the center here, we add them and divide by 2. And that is the median. Okay, so let me go through again. The median is when you had these two together and then you and divide by 2, which is 171 anyway. Okay? So, if they were different, you would still add them and divide by 2. The main thing in here is you're left with 2. Sometimes you're just left with 1, and that's great. That's the median. Okay, so that's the median. Alright. I've nothing else to add to this really. Now, floor down, round up, round down. Interquartile range, Q3 minus Q1. Anything else here? No. Big numbers, be specific when commenting. Okay, so your comments are your own, okay? Your interpretation of the data. Now I've come across interpretations of data and people have their own interpretations and that's not my problem, you know. But anyway, the next thing is that you try and do a question similar to this in 2013. There might be a stem and leaf there. Or look for a question in the sample papers, but do one, okay? That's great, thanks.